Hello everyone. Today we are going to see the analysis of wastewater sample with respect to chloride. It is how to determine chloride from the wastewater sample that we are going to see it today. This method uh, uses the Mohor's method, and we are going to follow the procedure according to the Mohor's method. Now let us see what is actual Mohor's method. We will see the principle of the Mohor's method. This is by using this Mohor's method, we are going to do the precipitation titration. Actually, there are 4 to 5 types of titration or volumetric analysis. Out of that, this precipitation titration, this is one of the type of volumetric analysis, and in this experiment we are going to perform precipitation titration, in which the silver ion is used as a titrant and chromate ion as an indicator, and this method, it is called as the Mohor's method. Now silver ions, silver nitrate we are going to use it, and potassium chromate we will use it as a indicator. Now this method determines the chloride ion concentration of the solution by titration with the silver nitrate ions. Okay, that is, in conical flask we are going to take chloride ions, and from burette we are going to add drop wisely silver nitrate solution into the chloride ion solution, so that there will be a formation of silver chloride white precipitate. And once the precipitation is completed, or once the chloride ions are completely reacting with silver ions, now after that there is no chloride ion in the conical flask to react with further drop of silver ions. So after complete reaction of chloride with the silver ions, chromate ions are going to react with the silver ions, and there will be a color change, and that color change is your end point. Now we will see the reaction. As silver nitrate solution is slowly added, a precipitate of the silver chloride forms. See the reaction. Ag plus, it is silver, aqueous silver ions, plus Cl minus in aqueous state, it will give AgCl, silver chloride precipitate, white precipitate. The endpoint of the titration occurs when all the chloride ions are precipitated. Now, then additional silver ions react with the chromate ions of the indicator, and potassium chromate to form red brown precipitate of a silver chromate. Okay, this is your end point. It is yellow to reddish brown is the end point of the titration. Initially, this two silver plus ions, they are reacting with after completion of chloride ions, silver ions which we are adding from the burette are reacting with the chromate ions. The chromate ion are having yellow color. Here there is a mistake. I had written it below silver plus ion, but it should not be there below silver plus ions. It should be there below chromate ions. Okay, chromate CrO4 2 minus. This is yellowish colored compound, and it is reacting with silver to form red precipitate of silver chromate Ag2CrO4. Now, solubility product of precipitate of silver halide is greater than that of the silver chromate, so that the solubility of the silver halide becomes less than that of the silver chromate. Therefore, precipitate of silver halide is formed first than that of the silver chromate. Okay, the stability, the silver chloride ions are having more stability than that of the silver chromate, and so first silver chloride ions are formed than that of the silver chromate. In other words, here I had written the same. Silver chromate precipitate has a greater solubility than that of silver chloride, and therefore silver chloride is formed first. And after all chloride ions are consumed, the first drop of Ag plus silver plus in excess will react with the chromate ion indicator, and it gives a reddish precipitate. That reddish precipitate, it is of silver chromate. Now here the reaction of standardization is given. Before using the reagents, we have to do the standardization of the reagents, and we will do the standardization of silver nitrate against sodium chloride, and the reaction in between them is NaCl plus AgNO3. It will give you a white precipitate of silver chloride plus sodium nitrate. And the chemicals required, first of all, the important chemical, that is your wastewater sample, then 0.025 normal silver nitrate, then 0.025 normal sodium chloride solution, and 5% potassium chromate indicator. Now how to prepare the solutions? Okay, this is a very important part, so I have included this also in this experiment. First of all, we will see how to prepare 0.025 normal silver nitrate solution. Now we will use here, whenever we will prepare normal solutions, we will use such a kind of standard equation. Is 1 normal 1000 ml silver nitrate corresponds to 169.87 gram. Now for silver nitrate, the equivalent weight and molecular weight both are same, so we are going to use here 169.87 only, which is the molecular weight of silver nitrate. Okay, so this is for 1 normal, so we will calculate it for 0.025 normal, and here I am going to prepare 100 ml solution. So for 0.025 normal 100 ml solution, how many grams of silver nitrate will be required, that we will calculate by cross multiplication. And similar calculations we will do it for NaCl also, but here we will take the weight 58.44, okay, which is the equivalent weight of NaCl. Now in procedure, first of all we will do the standardization of silver nitrate, and while doing the standardization we require both the solutions, 0.025 normal silver nitrate and 0.025 normal sodium chloride. First of all, we will take 10 ml of 0.025 normal sodium chloride solution in a conical flask, and in that we are going to add 1 ml of 5% potassium chromate indicator. This is yellow in color, so this the color of the solution will be yellow, and this solution we will titrate it with silver nitrate till end point. Okay, at end point we will get the color change from yellow to reddish brown, and the first reading we are going to note it as x1 ml, and in the same way we are going to take two more readings like x2 and x3 ml, and constant burette reading we will note as x ml, and from this constant burette reading we can calculate the normality of silver nitrate solution. Now let us see how to calculate the normality of silver nitrate solution. Okay, so during standardization, first of all in burette 1 we have taken 0.025 normal sodium chloride solution. Then in burette 2 we had taken 0.025 normal silver nitrate solution. Indicator we have used is 5% potassium chromate indicator, and end point is here yellow to reddish brown. So from burette number 1 we have taken 10 ml of NaCl solution for 3 times, and we will get the burette readings as x1 ml, x2 ml and x3 ml, and your constant burette reading is xml. So we will calculate now the normality of silver nitrate by the formula N1V1 equal to N2V2. So here N1 we have to calculate, x is nothing but your end point or constant burette reading, then N2 is 0.025 normal, which is the normality of NaCl. into V2 is 10 ml. Okay, so we have taken 10 ml of NaCl, so we have written here 10, and by the use of this formula we can calculate the N1, it is normality of silver nitrate solution. Now the next part of the experiment is estimation of chloride. Now during estimation of chloride we are going to follow same thing as that of the standardization, but instead of NaCl solution we are going to take the diluted water sample solution. Now let us see the procedure. First of all, whatever unknown sample solution is given to you, that sample solution you will have to dilute it to 100 ml with distilled water. Okay, you will have to remember in this, while doing this experiment, that throughout this experiment you will have to use distilled water only. Okay, you should not use tap water. So first of all we will fill the burette 1 with 0.025 normal silver nitrate solution, burette 2 with diluted water sample solution, and from burette 2 we are going to take 10 ml of diluted water sample solution in a conical flask, and then we are going to add 1 ml of 5% potassium chromate indicator, and that solution we are going to titrate it against silver nitrate till your end point will be yellow to reddish brown color. Okay, similar is the titration as that of your standardization, and here also you will get the same kind of end point, and the reading will be different, and we will note down that reading as Y1 ml. In the same way we can take 2 more readings, and we will note it down as Y2 ml and Y3 ml, and finally the constant burette reading we will note it down as YML, and by the use of this constant burette reading we can calculate the amount of chlorides present into the wastewater sample solution. Now let us see how to calculate the amount of chloride from wastewater sample. Now this is the observation table, and here in burette 1 we have taken 10 ml. From burette 1 we have taken 10 ml of diluted wastewater sample, and we have titrated it with silver nitrate solution, so that we got 3 endpoints Y1, Y2 and Y3, and the constant burette reading is your YML. So we will calculate now how amount of chloride ions present into the wastewater sample, and we will use here a standard equation that 1 normal 1000 ml silver nitrate corresponds to 35.5 gram of chloride Cl minus. Now why we have used here 35.5? This is nothing but the atomic weight of chloride, and whenever chloride is reacted with silver nitrate, it is reacting with silver Ag plus, and for 1 mole of Ag plus 1 mole of chloride is required to form a precipitate. So we are going to use here 1 mole of chloride, that is the atomic weight of chloride, and the atomic weight is 35.5 gram. So we have not used here one normal solution, so whatever the normality of the AgNO3, that we have to write here, N1 normal. YML is your burette reading, constant burette reading for sample solution, and for N1 normal YML silver nitrate we can calculate the amount of chloride or grams of chloride present, and consider that if it is capital A gram of chloride, and this A grams of chloride you will get it in 10 ml of diluted water sample solution, because for titration in conical flask we have taken only 10 ml of diluted sample solution. So whatever A grams of chloride you got, that you got for 10 ml. We have to calculate it for 100 ml diluted sample solution. So we will do cross multiplication, that is A into 100 divided by 10. Okay. After doing this calculation, consider that your final reading will be B gram of chloride. So this is nothing but your amount of chloride present into 100 ml of the diluted sample solution. Okay. So whatever chloride present in that diluted sample solution, same amount will be present in your given sample solution. Okay, because that given solution only we have diluted it to 100 ml. Okay, so finally we can write the result table as the first point in the result table, exact normality of our silver nitrate solution. As it is a secondary standards solution, we have to do the standardization of silver nitrate and we have to calculate its normality in every experiment. So that also we have to write. Second point is amount of chloride present in the sample solution, that is B gram, okay, which we have calculated finally. And this is the small procedure chart how to do the experiment. See, first of all we have to pipette out the sample and we have to take the sample, diluted sample solution in a conical flask. In that we have to add 1 ml of potassium chromate indicator, and because of addition of potassium chromate indicator the solution will be yellowish in color, which is shown here. And after that you will have to fill the burette with silver nitrate solution. Now here amber colored bottle is also shown, and that amber colored bottle, why it is shown? Because silver nitrate solution is always placed in amber colored bottle. So the silver nitrate solution from this bottle we will have to fill it in a burette, and we have to do next, in the next part we have to, in the fourth part we have to do the titration of your silver nitrate solution with that of your conical flask solution. Okay, so at end point this yellow color will be turned out to be reddish brown color. Okay, and this is your end point. So this is a small procedure chart how the color is changing. And